And welcome back. So continuing on the theme of covalent bonding, we're now going to look at the structures that are formed. So in this first video, we're going to focus on simple covalent molecules. Now this video is mainly a recap of what you did at GCSE. So hopefully you should know most of this already, if not all of it. But if you do have gaps in your memory, hopefully by the end of this video, be able to explain the difference between a simple covalent molecule and a giant covalent lattice. And you'll be able to link and explain the properties of a simple covalent molecule to its structure. So there are two major types of covalently bonded structure. There's simple covalent molecules, also known as simple molecular, and there's giant covalent lattices. So let's just look at a couple of examples to be able to explain the key differences between these two types of structure. Let's look at water, H2O, for the simple covalent molecule. And let's look at diamond for the giant covalent lattice. Now we will do more about giant covalent lattices in the next video. I'm just going to use this one as an example to go through the differences between these two different types of structure. So first of all, let's just look at the formula. We obviously have H2O for water. In diamond, we just have C for carbon, because each atom in diamond is a carbon. Now, with water, H2O is the exact formula for the molecule. In each molecule of water, there are 2 hydrogen atoms bonded to 1 oxygen. This is what we call the molecular formula. It's the exact number of hydrogen atoms, the exact number of oxygen atoms, or atom in this case. So there is a finite number of atoms per molecule. Normal water will always have 3 atoms per molecule. Now diamond, on the other hand, the formula is just C, but we can see from the diagram there isn't just 1 atom. Because it's a giant lattice structure, there is potentially, or theoretically, an infinite number of atoms it can contain. It just repeats itself in the same pattern in all directions. So with a giant covalent structure, the exact number of atoms is unknown, and the formula just gives you a ratio. Now, in diamond there's only carbon, but there are other giant covalent substances where there's more than 1 element, and their formula will just give you the ratio of atoms within that substance, much like you've already seen with the giant ionic lattice. So this is the difference between the two types of structure, and this leads to different properties between the two. So that's why we're not going to do them both in the same video. I want to focus on simple covalent molecules in this video, and we'll look at the properties of different types of giant covalent lattice in the next video. So I've just picked 2 different simple covalent molecules to go through as examples. So I've picked water and carbon dioxide. So hopefully you should be very aware of these 2 different molecules. So now let's go through the properties you need to be aware of. Okay, so the melting boiling point of simple covalent molecules is very low. Now not only do you have to know this fact, you have to be able to explain why. Now when you melt a simple covalent substance, think ice, okay? Or the same when you boil a simple covalent substance. The key point here is that you are not breaking any covalent bonds. You're in fact breaking what are known as intermolecular forces. Now, intermolecular forces are forces of attraction that occur in between molecules. Intermolecular, in between molecules. So these attractions are what are holding the molecules together in either the solid or the liquid. And it's these forces which are broken when you go past the melting point or the boiling point. Now these intermolecular forces are weak in comparison to proper bonds, covalent bonds, or ionic bonds. So therefore it does not take as much energy to break them. Hence, the melting or boiling points are lower. Okay, these are the phrases, the step-by-step phrases you need to be including in answers about melting and boiling points. Okay, you need to identify the force, in this case, or the bond which is being broken. You need to link this to the amount of energy required to break it. So we're breaking intermolecular forces. They're weak, so they don't require much energy to break, hence low melting or boiling points. Now you should have also done this at GCSE. In Unit 2, we will actually be going through different types of intermolecular force, but in Unit 1, you're not expected to know it yet, so you can just describe it as an intermolecular force. The second property you need to know about is whether these substances conduct electricity, and the answer is no they don't. If you think back to the ionic structures video, we went through what a substance needs to have to be able to conduct electricity. Hopefully you can remember. It needs charged particles, and they must be able to move. So these charged particles are either delocalized electrons or they are ions. Simple covalent molecules contain neither of these. There are no charged particles, therefore they will not conduct electricity. And these are the two major properties you need to know about. So you need to be able to know the trends and be able to explain them and link the explanations to their structure. So hopefully this has been a reminder on the difference between a simple covalent molecule and a giant covalent lattice, and the key properties of simple covalent molecules and how you link it to their structure. So make sure you complete your notes, and I'll see you in class.